Rabbi israh li sadri yassir li amri wahlul 'uqdatam min lisani yafqahu qawli Rabbi zidni ilma warzuqni fahma amin ya rabbal alamin. Before we begin, as usual, we will take picture together. And unfortunately, Dr. Mark is not here, but that's fine. So guys, if you have a camera in your device, please turn it on because we need that as approval for your certificate in the end. All right. Brian, Heb, Aiman, I think I'm Leia, Jennifer, please turn on your camera. Razan, Noor's iPad. All right. Adlil.
08 2011 berapa sih?
Riko mulai Bapak. Riko? Yes, please.
Secis 1, 2, 3. Sekali lagi 1, 2, 3. Sudah Bapak.
Thank you. Mark, don't forget to take the attendance. And also, Bilasan, don't forget to provide the link for Google Form attendance.
Yes, Doctor.
Where is Bilasan? Where is it? Where are you, Bila?
I'm here, Dr. Febrian.
Okay. Many pictures in front of me. Let us begin our class today. Wait. Where is my? Oh. Right. Cancel. Co-host, please approve the participant. Yes, thank you. Share, keynote, put it here. All right, can you see my slide, Bila-san?
Yes, I can see that, Dr. Febrian.
Today is the second class, and the title. Hello.
Yes,
Can you
I
hear
can
me
hear
now?
you now.
Oh,
Yes, I can hear you now.
Oh, someone trying to mute me. Oh dear. All right, guys. Today is the second lecture, and the title. Bro, can you hear me? Bro, can you hear me? Okay.
Yes, I can hear you. Okay.
Because this is in English, please mention me go up a bit. Okay, two say one is on now. And two, the session will be the session of module A1. And the session 2, I will be helped by Dr. Lucia, Dr. Pera, and my assistant. Where are you, Chacha? Oh yes, there you are. So the title consists of 3 big jargon: exposition, quantum mechanics, and molecular physics. In the right side of this slide, you will see a definition of each term. We have first A, we have diagram fan, science, engineering, not English, engineering and computer science. B, mathematical description of particle. using wave behaviors, or vice versa. C. Explanation plus elucidation plus interpretation. Judul kuliah kita memiliki 3 jargon: eksposisi, mekanika kuantum, dan fisika molekular. Di sebelah kanan slide ada definisi. A. Diagram Venn. Ada science, ada engineering, dan ada ilmu komputer. B. Deskripsi matematika dari partikel yang berperilaku seperti gelombang atau sebaliknya. Dan C. Penjelasan, membuat sesuatu lebih jernih, dan interpretasi. Your task, guys, I will not give you the answer. Your task is to match which one belong to which one. I give you a clue. Perhaps the color answers. Exposition is this one, perhaps. All right? Exposition, quantum mechanics, and molecular physics. So you can guess the answer already. I think Dr. Mark will put it in the quiz in the next quiz. All right. This is what we have done so far. So in science, in the perspective of science, up to the late 1890s, chemistry heroes already uncover the Earthling universe. Segala sesuatu yang ada di muka bumi sudah dijelaskan oleh para kimiawan. Para kimiawan merasa we know everything already. There are 4 formula, there are 4 recipes. Ada 4 resep, 4 recipes to understand this Earthling universe, alam yang ada di muka bumi ini. 1. Periodic table. Second, Lewis structure. Third, spectroscopy. Either it is infrared or UV vis. Dan yang terakhir, the knowledge of chemical bonds that we have: covalent, ionic, hydrogen, or van der Waals, and so on. Okay, ada 4. There are 4 recipes to understand the universe on the earth, not above the earth. Di dalam kehidupan in daily life. Alright? Unfortunately, when chemists face ozone, these 4 recipes doesn't work. According to these 4 recipes, ozone should be unsymmetric, not symmetric. Ozone, you see, there are 1 double bond and 1 single bond. And double bond must be shorter than single bond. That's according to the 4 recipes. But when they look at to the infrared spectrum, UV spectrum, and so on, they found out R1, and R2, the bond length for these 2 length or bond are equal. Understand? Menurut 4 resep tadi, ozon itu harusnya tidak simetris. Satu ikatan lebih pendek dari ikatan yang lain. Karena ikatan double bond itu lebih kuat daripada single bond. Semakin kuat ikatan, the stronger the bond, the shorter the length. Jadi, menurut 4 resipi tadi, ini dia. Kenyataannya sama. When they look into the experiment, they found out that the ozone are symmetric. And ozone is not the only molecule have this feature. Another example is benzene. Benzene, according to these four recipes, is something like this. Double bond, single bond. There is a song about this. Double bond, single bond, double bond, single bond. The short, sorry guys, the double bond always shorter than the single bond. So according to this, our conventional chemistry, benzene is not symmetric. However, when they looked into the experiment, they found out benzene is perfectly symmetric. So something is not correct, either our eyes through the experiment or these four recipes is not enough. Saya ulangi, menggunakan 4 resep tadi, ternyata ada beberapa dan tidak beberapa banyak molekul yang tidak memenuhi 4 resep tadi. Sehingga tidak mungkin kita menggunakan 4 resep tadi untuk melakukan banyak hal. Malu kita, masa ozon saja tidak mengerti? Masa ozon saja tidak mengerti? Masa benzen saja tidak mengerti? Bagaimana kita bisa mengerti kehidupan? Padahal kalau kita lihat, if we look at back to this diagram, simple diagram, you know what A is? It is molecular physics. Jangan tertipu with the color, okay? Do not deceive your eyes by the color. This is molecular physics. Molecular physics is interdisciplinary field between science, engineering, and computer. Molecular physics is in the middle. Jika molecular physics cannot deal with ozone, we cannot deal with anything. Paham ya? Therefore, I told the story about my father already last week. My father went to the seminar, to the group of Linus Pauling. I didn't know that he met Pauling that time. I think he didn't meet because Pauling was already all the time. But he went to the group. And when he returned to Indonesia, he explained to me the electron configuration when I was in the junior high school. This one. And the second gift my father gave me is the story of Linus Pauling. Hadiah pertama adalah ilmu tentang konfigurasi elektron, hukum Hund's law, Hund's rule. Dan yang kedua adalah the story of Linus Pauling, including when he explained to me about, I hope this is video, coupled pendulum resonance. You see what happened, right? You see it, right? Make it fast. So let us begin. First, both pendulum are at rest. One pendulum forced to move like this. But in the end, the first pendulum begin to slow and the second pendulum moves. You see that, right? Look. And first pendulum in the end will stay at rest. And pendulum second becomes moving faster and faster. And now the other way around, and so on. So we call this system is coupled pendulum resonance. I will not explain any further because we want you guys to go to Google, go to ChatGPT, type this keyword, couple pendulum resonance, and find many animation, many explanation, especially Indian guy. Indian uncle is very smart to explain to you with the easiest way. If you listen to Dr. Mark lecture for 3 hours, go to YouTube, only need to 3 minutes to understand. Indians, Uncle Indian. Okay, guys, I will continue. And this is what happened. My father told me when I was in junior high school. Pendulum, the pendulum illustrated by this sketch. You see A and B, and there is a spring. Spring is just imagination. It is not there actually. It is just to explain how the energy transfer, and the spring is the medium. A and B are one system. That's why we call it couple. So they are not two systems. They are one system, contain two pendulum. So that's why we need to connect them with spring. Imagination, not the real spring. A, the first one is moving is A. B is quiet, at rest. And in the end, moving, and finally slow. B now becomes move, and faster, and then slow again, and then, yeah, like this. A moving, B at rest. B moving, A at rest. A transfers energy to B. A is to rest, A akan istirahat, while B is moving, vice versa, sebaliknya. Paham ya? A dan B, kedua pendulum itu satu kesatuan. Itu sebabnya kita sebut dengan couple. Gambar saya terlalu besar ya. Setiap saya bergeser, kameranya mengikuti. Not good. I will open my second camera. Wait, bro.
Sorry, I can't hear you. Can you hear
Yes,
me?
something is not correct. Now can you hear me now?
I can hear you.
When I am opening my second camera, the microphone mute. But I think it is okay now. Test.
Yes.
Oh,
Okay.
okay. Jadi pendulum A dan pendulum B itu satu kesatuan. Satu kesatuan. Mereka bukan dua sistem terpisah. That is why we call it coupled pendulum, sepasang. Seperti sepasang suami istri, satu kesatuan. A pertama bergerak, B diam. Setelah sekian lama, A mulai bergerak pelan-pelan, B mulai bergerak cepat. Lahirnya A berhenti, B bergerak. Dan B terus bergerak dan pelan-pelan juga mulai diam, pindah lagi A yang bergerak. Paham ya? Kita sebut E mentransfer energi ke B. Karena transfer energi inilah B bisa bergerak. Dan begitu sebaliknya. Energi akan ditransfer balik dari B menuju A yang bergerak. Point 2 that we just discussed, point 2, it is an internal affair. Masalah internal. We are from external. We don't know what happened inside the box. We don't know what happened inside the box. According to us, external, we only can say that the system keep moving. Sistem terus bergerak. Walaupun pergerakannya berubah-ubah. Sekarang A yang bergerak, B diam. Kemudian B yang bergerak, A diam. Kemudian A yang bergerak, B diam. Itulah yang kita sebut dengan resonansi. Secara fisik, secara matematis, resonance is when the position depend on the other position. Posisi A, fungsi dari waktu, the pendulum A position is a function of time and the function of position B. This is what we call position interdependence. This is resonance. You heard about resonance adalah turut bergetarnya benda akibat benda lain bergetar. It is correct. It is good. But it is in elementary level, elementary school level. We are in university student. If someone asks us, if your grandfather at home asks you, Cucu, what is resonance? The answer is, ketika sebuah sistem, posisi partikel-partikel di dalam sistem itu saling bergantung. Position interdependence. That is resonance. Baik. Sekarang, ayah saya, now, my father explained to me after his success to make me understand how the couple pendulum work, he brings a new case, which is the ionic hydrogen, H2 positive, the most simplest molecule. We have two hydrogen, but with one electron. That's the most simplest molecule. And then my father asked me, you have two options, he said to me. Either the electron, the only electron in the molecule orbiting nucleus A, this figure, or it is orbiting nucleus B. You got it? Either this one or that one. Which one do you choose? Of course, I was smart that time. I'm not really smart right now because since I met Mark, Mark is more smarter than me, Dr. Mark. So I cannot claim myself smart anymore. But during that time, I was really smart. I know that why my father explained to me couple pendulum first before he provided me this figure, because he wanted me to connect the dot. My answer is both. The system contains both configuration. First, electron 1 orbiting nucleus A, and the next few times later moves to orbiting nucleus B, exactly like what couple pendulum resonance. First, A is moving, B quiet, and then B moving, A quiet. This is exactly what happened in hydrogen, ionic hydrogen molecule. My father was so proud and he gives me bicycle. I still kept the bicycle at home right now. Small bicycle. I gave it to my nephew already. It is not mine anymore. But that's true, Dr. Mark. I was so proud. Junior high school can answer that question. No mathematics, only figure. My father is really smart using illustration. So this is resonance. This is resonance. You can explain resonance. You can explain resonance from the classical, the pendulum, and bring it to molecule like what we just observed here. So first, electron A is moving, is orbiting nucleus A, and then in the few hours or in the next time, moves to B, and then moves back to A, and move back to B, and so on. You got it? All right. And this is also resonance because now the position of electron A depends on the time and also depends on the position of B. Interdependence. And the one that comes out this explanation is no one or no other than Linus Pauling. And he used exactly the same ionic molecule H2. And then from molecule ionic H2, he explained ozone. So he said that, look, electron here, we have 4 electrons here according to Lewis here. This electron, these 2 of 4 electrons can move to the next bond. And then moves back to the next bond. And then moves back to the next bond. What happened during the experiment is, when you look at the ozone, you not only see one single ozone, you will see bunch of ozone. How many? 6 to the 6.0, 6.02. I forgot the numbers. How many, Mark? 6.022 times to the 10 to the power of 23, right?
Yes, correct.
That's at least that's a number of molecule of ozone you will see in under microscope of experiment. Not only one. And some molecule you see this, some molecule you see that, some molecule you see this, and you take the average. What you get? Symmetric. So this is how Linus Pauling explained to chemists, this is what happened in resonance structure. And to do that, people will ask, how do an electron moves from one to another nucleus? Who asked? This is our icon right now. Last year is Aksa Nur Hasanah. This year is Hilal Nur Shawal, our another cat. And because he is a cat, so he doesn't care that he cover the text. So don't mind about that, okay? This cat, kucing, yang namanya kucing kan egois. So you will ask, you must ask, like Hilal Nur Shawal asked, what the question? How one electron from nucleus A can transfer to nucleus B? Because if we go back to the pendulum, we have 1, 2, 3, 4 procedure. And if we concentrate to this procedure, point 2, transfer energy, we know exactly why B is moving, because they got B got transfer, money, got money transfer, and then he is rich. Now he can do whatever he wants. So something transferred to something else. So that's why B can move. The next question is, how does energy transfer? Bagaimana caranya elektron bisa pindah dari A ke B? Kalau kita kembali ke sistem pendulum terkapel, pendulum terpasangkan, yang berpindah adalah energi. Yang berpindah adalah energi dari A ke B. Nah, kalau yang berpindah adalah energi, bagaimana cara energi berpindah? We will have many questions if we accept Linus Pauling explanation, then many question rises. Banyak pertanyaan yang bisa muncul kalau kita menerima penjelasan Linus Pauling. Linus Pauling is my hero. Schrödinger is not my hero. The answer is, how does energy transfer? The answer is dalam bentuk gelombang, in the form of wave. Di dalam pendulum terpasangkan, in the couple pendulum, we have spring. That's why we need spring. Imaginative spring. It is not really there. Spring is to mediate the energy transfer from A to B. What happened when the energy transfer from A to B through spring? Spring is vibrating, oscillating. Oscillating is wave. Mahasiswa Dr. Vera sedang ada yang sudah mengambil atau sedang mengambil fenomena gelombang, ini terpakai. Wave phenomenon. Di sebelah kiri kita punya spring sebagai bentuk energi, sebagai bentuk gelombang. In the couple pendulum, we have spring to represent the wave. Why do we need wave? Because energy transfer in the form of wave. That's physics. This just believe me right now. If you need to transfer money, you need internet. Internet also wave. So money is energy. If you want to transfer energy, energy must be transferred in the form of wave. So you know Tai Chi, right? Tai Chi also wave. I will transfer my power to you now through wave. I keep looking at the wrong camera. My camera is there now, but I look at there. Okay, Dr. Mark, so far, do you receive my energy so far?
Yes, I've received through wave.
Energy must be transferred in the form of wave. That sentence for at this time, just take it for granted. It is disclaimer. If you want to go further, you can come to class Dr. Vera, named Fenomena Gelombang. In the couple pendulum, the wave, the energy transfer via spring. Jadi pegas di sana tujuannya adalah bentuk atau manifestasi dari gelombang. Di dalam gelombang ada energi. But in the molecule, the ionic H2 hydrogen, ionic hydrogen, we don't have spring. We only have electron. The one that must be transferred is electron, not energy. How? The only possible, no other choice is the electron must behave like wave. The electron must behave like wave. Elektron di pendulum kita ada spring. Di molekul ionik hidrogen tidak ada pegas. Yang ada elektron dan yang bergerak adalah elektron. Satu-satunya kemungkinan yang terjadi di dalam molekul ionik hidrogen adalah elektron satu-satunya itu berperilaku seperti gelombang. Kalau dia gelombang, dia bisa berpindah kapan saja dia mau. Oke, guys. Lanjut. Dapatkah can electrons really behave like wave? Bisakah elektron benar-benar berperilaku seperti gelombang? Let us see the following argument. Particles have mass. Partikel punya massa. It can be at rest or in motion. Because particles have mass, karena partikel punya massa, dia bisa diam, partikel bisa diam seperti kita sekarang ini diam, atau kita bisa berlari, in motion. However, wave has frequency. Gelombang punya frekuensi. Konsekuensinya, the consequence is wave is always moving. Kalau ada frekuensi, pasti dia bergerak. If the frequency is zero, it is not wave. Wave, the frequency must be always bigger than zero. As the consequence, wave is always in motion. Alright, when hitting a wall, ketika menabrak dinding, particles bounce back. Momentum ya, tumbukan. Sementara when hitting a wall, some part of wave bounce back, some of them can penetrate the wall. Kalau partikel pasti mantul, kembali, bounce back, gelombang ada yang bounce back, ada yang lewat. Paham ya? The conclusion is particle can never behave like wave. Kenapa? Partikel bisa diam, gelombang tidak boleh diam. Partikel bisa diam, gelombang tidak boleh diam. Partikel pasti bounce back. Pasti bounce back. Sementara gelombang can penetrate it. Gelombang can penetrate while particle must be bounced back. Kesimpulan, partikel tidak akan pernah bisa menjadi gelombang. Particle can never behave like wave. Tidak bisa berperilaku seperti gelombang. We have to be careful here. We cannot say we are not allowed to say that particle change to wave. No, it is not a correct statement. It is not correct statement. Particle is always particle. Wave is always wave. But now we are talking about behavior. Okay, like in human, we have boys behave like girls, or vice versa. But boys still boys. It doesn't matter how gemulai he is still a boy. Paham ya? Begitu juga di sini, what we are talking about is the behavior, perilaku. Dapatkah elektron berperilaku seperti gelombang? According to this statement, cannot, never. However, in 1923, this is not correct, this is 1923 until 1927, two physicists proved otherwise. The right side, I think you are familiar with this. This is Thomas Young experiment. This guy, Dr. Mark, is always muda. Dia awet muda. Karena namanya Thomas Young. It doesn't matter how old he is always young. This is Thomas Young experiment talking about light or wave interference. So cahaya gelombang, wave, can interact with themselves. Self-interaction. Self-interaction. Kalian bayangkan, kalau kalian ada dua orang, kalian lihat teman sebelah kalian ya, you look at your friend, find your friend, one couple, two person, one gendong, angkat, lift another one. What happened? What happened? Yang satu naik ke atas, yang satu tetap tinggal di bawah. Okay, that's how you lift your friend. You know, ya gendong ya. Now the question is, can you gendong yourself? If you can gendong yourself, we call it self-interaction. It happens in light in wave. Wave can interact by themselves. So this is what we call interference. Particle cannot do that. We are particle. We cannot interact by ourselves. If we interact by ourselves, people will call us Gila. Why are you talking with yourself? Why are you smiling without reason? Kenapa compare? But no people around us, we keep talking. We are crazy. All right? Particle cannot interact with themselves. Particle can interact with other particle. Particle can interact with other particle. If particle interact by themselves, what we call it? Crazy. Orang gila. But wave can. Gelombang bisa berinteraksi dengan dirinya. That is what we call interference. But somehow, Davison and Germer prove by some circumstance in the special condition, electron can interact by themselves and they can make interference as well. So before this, interference only happens inside wave. Interference hanya terjadi di dalam gelombang. What happened with Dr. Mark? Oh, he missed a lot of my joke. Dr. Sylvie, Lucia.
Yes, Dr. Fabian.
What happened, bro?
Sorry, my battery was low.
Ah,
I connected
you
it.
missed, you missed a lot of my jokes, bro.
Is it? Sorry, please carry on.
I repeat it again. It is important. I will go back because why do we have here this slide? We have to go back. Jadi di sini ya, di sini in this slide we got the conclusion according to Linus Pauling, resonance is real. The structure, the ozone structure, the benzene structure that not obey Lewis structure is real. Lewis structure is not complete, not wrong, but not complete. If we really want to understand how ozone structure is, we have to consider them as resonance structure. What is resonance? Resonance is the electron can move from one position to other position whenever he wants, whatever he wants. Nobody can control it. I want to be here now. Okay, now it is really like a cat, kucing. Kucing, it doesn't matter how love you are to your cat, how love you treat your cat very well. He doesn't care. He will do whatever he want, like hilal. Jika if electrons can move to wherever he wants, the requirement is he must behave like wave, because only wave can do whatever they want. Particle cannot. Particle has many restrictions. Seperti rambu lalu lintas, traffic lights. You must stop here, you cannot go to turn right, and so on. But if you are a wave, you don't care about the traffic light. Now, resonance structure require electron can move to whenever he wants to move. It means electron must behave like wave. You have to write it down because I believe this is the another question from Dr. Mark in the next quiz. I give you the bocoran. Yeah. What is bocoran? Now the question is, if electron must behave like wave, can he do it? Can electron do it? And according to our logic, it cannot. Electron cannot behave like wave until Davison and Germer prove that electron can make interference. Interference is unique to wave. Interference is was unique to wave. Electron cannot do that. But somehow it happened during Davison and Germer. And many experiments after that prove this. Of course, there are certain conditions, because if the condition does not meet, you will see this. This is not interference. This is interference. If you don't see, this is really famous meme, you know, in internet to explain the interference of electron. If you don't see it, you will see electron. You will get the electrons interference. If you look at carefully, you don't see it. But this is something else. It is what we call Heisenberg uncertainty principle. But this is not our story right now. Our story is electron in certain condition, you can make it behave like wave. Right? In certain condition. What is the condition? It is another story. But the bottom point is, yes, electron can behave like wave. That's why, without a doubt, electrons can behave like wave. Then the question is, but how? At this point, no one cares anymore. Why? Because the news is so big. The proof is so solid. People doesn't care anymore how electron can do that until, this is something that I don't like to talk, until Schrödinger comes up. The story is not really good, but I will tell you the story next time. But anyway, before we go to the Schrödinger equation, we have to understand that physical objects only in this universe, only two families of physical object. Either it is particle or it is wave. And once it is particle, it will be particle forever until the judgment day. If it is wave, it is always wave until the judgment day. It will not change. So if someone tells you particle can become wave, it is a lie. Or someone can tell you wave is particle, particle is wave, it is lie. It is not correct. Particle is always particle until the judgment day, until kiamat, and wave is always wave. Even you go to the quantum second quantization, particle is always particle, wave is always wave. Right? Then let's go. Particle, if you study particle using equation of motion, okay, persamaan gerak, equation of motion. You use equation of motion of particle, so you have particle, you study particle using persamaan gerak particle, that is what we call classical mechanics. Okay. If it is wave, jika ini adalah gelombang, you study the wave using equation of motion for wave. This is also what we call classical mechanics. I will not go into detail. Forget about the equation. We don't need equation here. Just a name. Persamaan gerak partikel untuk mempelajari partikel. Persamaan gerak gelombang untuk mempelajari gelombang. Equation of motion for particle, we use it for particle. Equation of motion for wave, we use it for wave. Paham ya? Piring kita isi dengan nasi. Piring kita isi dengan nasi. Gelas kita isi dengan anggur. Dengan air. Right? Plate, we put rice on it. While glass, we fill with water. That's classical mechanics. That's classical mechanics. Now you put it in different place. You have plate, but you put water on it. You have glass, you fill it with rice. Got it? That's quantum mechanics. If it is particle, you study it with wave, equation is quantum theory. So you flip it. You flip it. So that's why, Dr. Mark, if you go to pernikahan, pesta pernikahan, wedding ceremony, and you see some people, they put ice cream on the plate, perhaps he is using quantum theory. And they bring glass full of rice, full of roti canai, that perhaps he is using quantum theory. And we are going to learn the red one. Schrödinger equation is here. Okay, this is Schrödinger equation, the red one. So that's why Hilal say our pathway, but he covers the pathway. All right, guys. So easy, gampang ya, mudah memahaminya. And I keep looking at the watch. What did we discuss so far? First, listen carefully. Not what happened? Okay. Oh, I have to repeat it again. Yang terjadi, Cah? Okay. Not even ionic hydrogen can be explained by conventional chemistry. Not to mention ozone and benzene. Jangankan ozon dan benzen, 4 resep kimia yang hebat tadi yang kita sebut sebagai conventional chemistry cannot explain H2+, ion H2+. Resonance structure, ya, untuk menjelaskannya kita butuh to explain them, we need resonance structure. And resonance structure, another solid proof that particle may behave like wave. Davison and Garmer is another solid proof. So that's why Pauling got Nobel Prize. Not only because he explained many things about the bond, but also he provide another proof that particle, electron, can behave like wave. Otherwise, we cannot explain ozone. When particles behave like wave, we must wear, kita harus pasang kacamata hilal. We cannot study them using classical mechanics. We must study them according to hilal, quantum mechanics. But I promise to you that I will not use quantum mechanics. I will use hilal's eye to replace quantum mechanics. Because I know some of you, many of you, are quite traumatized with trauma dengan quantum mechanics. But I promise you, quantum mechanics is beautiful. But I understand because some reason you care about quantum mechanics, we replace it with hilal. We shall discuss quantum mechanics or the eyes of hilal next week. And we have to go to the next session. We take a break for 10 minutes. And then we continue to discuss with module A1 that we believe that you already did it. And for that, I will ask help to Dr. Lucia. Where are you? Dr. Lucia, Dr. Vera, and Chacha. Where is Chacha? Yes. Are you ready, guys? 3 of you. So Dr. Lucia, listen, Dr. Mark will give demonstration, right, Dr. Lucia?
Yes, Dr. Febrian.
Thank you. And we will take break for 10 minutes. So you can take a note. Perhaps you have some question that you can also ask during this session. Bro, that's all for, where is Dr. Mark? That's all for this session. So we will take 10 minutes break.
Okay, sure.
Then
We'll,
it's not like this. This is dada. This is goodbye. This is 10 minutes break.
okay, we'll be back.
Yeah. Thank you, guys. I'm sorry, bro. Sorry. We will take another photo session. We need 3 photo sessions. Where is my camera? We need 3 photo sessions. Okay, guys, please turn on your camera. We need 3 photo sessions. Rico, are you ready?
Sorry, I just have a question.
Ready, Bapak.
about the attendance? Last week, we supposed to fill in the
Yes.
attendance, but we are not able to log in. I mean, we're not able to fill out the form. We're not given permission to fill out the form. But the new form this week, we're able to do so.
Ila, can you help us?
Yes, I can, Dr. Febrian.
You only have one job to do. Okay, that's another story. All right, Tico, please help us.
Please smile. 1, 2, 3. Again. Please smile. 1, 2, 3. Sudah,
All
Pak.
right. Thank you. And before we take a break, student from Unair, Gabriel, Naufal, terima kasih. Ada Sabsina. Berikut ini kita akan masuk ke sesi demonstrasi. Karena kalian juga masih ujian. Oh, sudah selesai ujiannya ya. Tapi kalian boleh tidak mengikuti. Jadi ada Anissa, terima kasih Anissa. Kalau kalian mau ikut boleh, kalau tidak juga tidak apa-apa. Terima kasih ya.